All right, continuing with the review for Unit 4A, 37. So they want us to find the arc length. Okay, so for the equation for an arc length, this actually goes back to geometry. We did similar questions to this. Oh, I got an interruption here, sorry.
Kayla Broussard, please come to the main office. Kayla Broussard, please come to the main office.
So arc length is equal to the radius times the theta, or the angle that we're using. Okay, and so they tell us in 37 that find the arc length of on a circle with a radius of 20 and a intercepted by a central arc of 138 degrees. Okay, the big thing we want to understand is we want to do this in terms of radians. Okay, we want to do this in terms of radians. So I can either convert it to radians now or do it at the same time, whatever the case may be. I'll go ahead and I'm going to do it right now. So 138 all over 1 times pi over 180. Okay, that's degrees right there. Okay. And if I do that, I can reduce it down. So kind of getting started over here. So it's going to be S equals 20, okay, times this. So I got to reduce these down. Obviously, I can take a 2 out, so I'll just do that real quick. If I have a calculator, it'll be a little bit quicker. But I'm basically going to say, all right, so half of 138, so half of 130 that's 65. So that's going to be plus another 4, so that's going to be 69. Okay. Over 90. Okay, but realize I can take a 3 out of those, so that's 23 over 30. Okay, so that's 20 times 23 over 30 pi. Okay. And then I can reduce right here, and I'm looking at 2 times 23 over 3 pi, and that gives me 46 over 3 pi. Okay, 46 over 3 pi. If I wanted to turn, I can punch that into my calculator if I wanted to, and I could get, it's about 48.2 millimeters, or meters, yeah, whatever the units were. Okay. Moving on to number, that was 37, so we're on 49 now. Okay, so 49 is asking us to find all 6 trig functions for pi over 4. So if I was to just kind of put this on the unit circle, pi over 4 is right here. Okay, and if I remember, if this is a unit circle, I'll just use from that perspective. Here's my end, and so this is the coordinate point, root 2 over 2, root 2 over 2. Okay, so I'm going to use a unit circle, so my radius is 1, so now I'll go ahead and find my, my functions here. So the sine of pi over 4, the cosine of pi over 4. I'm just going to go ahead and find these 3, and I'll let you do the reciprocal ones by yourself. And tangent pi over 4. So if you remember, the sine is equal to the x-coordinate, the y-coordinate over the radius. The radius is just 1, so that's it. The cosine is equal to the x-coordinate, which is the same thing. And the tangent is equal to the y over the x. And that's the same thing on top and bottom, so that's just 1. Just 1. Okay. And then 51. Okay, 51, they want the same thing, but in this case they give us 2 pi. So I'm right here at 2 pi. Okay, I'm at 2 pi. So 2 pi are really 0. It acts the same. So this is the coordinate point. If I use the unit circle, there's a radius of 1. So I kind of get to ignore it because it's, in the formula it's just the bottom number. This is the coordinate point 1, 0. Okay. So same thing, the sine of 2 pi is equal to the y-coordinate over the radius. the cosine of 2 pi is equal to the x-coordinate over that, and the tangent is equal to the y-coordinate over the x-coordinate, and so that is 0. Okay, that is 0. So that was number 51. Okay, moving on to number 59. Okay. 59 says evaluate the trig function using the period, okay, as an aid. All right, so this is basically the sine of negative 17 over 6 pi. Okay, so I have one ray of hope here, is that I see the that it has the denominator of 6. So I know it's going to act like my measures of 30. The problem is it's not in, I don't know the reference angle right away exactly. I do know the reference angle of 30, but I don't know which quadrant it's in. It's a little bit weird because it's bigger than 2 pi. So I want to try to get it down to under 2 pi so that I can find out what quadrant it is. Makes it a little easier for me. So what I'm going to go ahead and do is I'm going to first go ahead and add a 2 pi, take one revolution off, okay? So that's going to be negative 17 pi over 6 plus, getting a common denominator, 12 pi over 6. So that gives me negative 5 pi over 6, okay? And I could go ahead and use that. I could just run it backwards. That wouldn't be that big a deal. But just to make my life a little easier, I'm going to go ahead and just do one more. So I can get it into the positive one and to make my life a little bit easier. And so that's 7 pi over 6. Okay. So if I throw my unit circle on there, okay, and I ask myself basically where is 7 pi over 6? And that's over here in quadrant 3. It's right here. Okay. And so they want the sine, okay? So they want the sine of it, so that would actually be, okay, so this is my pi over 6 scenario or reference angle, and that's the case where it's the coordinate point root 3 over 2 and a half, okay, but I haven't talked about the negative or positives yet, right? So I'm in quadrant 3, so my exit, my x and my y are both negative. The sine is the y value, okay? So I can go ahead and say the sine of negative 17 over 6 pi is equal to negative a half. Okay, negative a half. 63. So they want us to know, hey, this is talking about even or odd functions. And so they say the sine of negative t is equal to negative 2/3. Okay, so what is the sine of t? Okay, and what is the cosecant of t? Remember, they go together. So if you remember, the rule is, this is an odd function, like, so if I said the sine of 2/3, or sorry, the sine of some theta, okay, I'm just going to make some numbers up here, is say 37 degrees is equal to 1/5. I don't know, I'm just randomly making up these numbers. So if I do this, if I make it negative, it would make the sine, the actual answer, also negative. Okay, sine does that, cosine doesn't. That's why they call it an even function. So with that being said here is, so they're giving me this scenario and they want this scenario. So up here this is positive 2/3. Okay? Well, if the sine of t is positive 2/3, then the cosecant is simply the reciprocal. And there you go. Okay? So these signs will match with sine and are odd functions. Okay? Cosine, they always come out positive. Okay? And there's a graphical representation about what quadrants they're in to explain that.